Hi, welcome to Mrs. Park's Algebra 1 class. This is finally Chapter 6, 6.1, Graphing Systems of Equations. Okay, so why are we doing this? Alright, so here's a scenario where you would use this in a real-life situation. The cost to begin production on a band CD is $1,500. Each CD costs $4 to produce and will sell for $10. The band wants to know how many CDs they will have to sell to earn a profit. A lot of these scenarios for solving systems is to find when will they break even. Alright, graphing a system can show when a company makes a profit. The cost of producing the CD can be modeled by the equation y equals 4x plus 1,500. It's going to be 4 times each CD plus the 1,500, where y represents the cost of production and x is the number of CDs produced. The income from the CDs sold can be modeled by the equation y equals 10x. So every CD they sell times 10 is their income, where y represents the total income of selling the CDs and x is the number of CDs sold. If we graph these equations, we can see at which point the band begins making a profit. So there are your two graphs, and this point right here is when they actually start making a profit. So the point where the two graphs intersect is where the band breaks even. Anything that goes higher than that is where they start making more money. This happens when the band sells 250 CDs. If the band sells more than 250 CDs, then they will start making some money here. Okay. Alright, so when you're doing these systems, there are going to be 3 possible solutions. There's going to be exactly, when you have a graph like this, like the one we just looked at, they meet at one point, exactly one solution, then you say they're consistent and they're independent. When you have only one graph, it's infinite. There's infinite possibilities on this one graph. It's also consistent, but this time it's dependent. When there's no solution, it's when you have 2 lines that are parallel. They're inconsistent. So they will never meet. That means there's no solution and they are inconsistent. Okay. So this is where it's your turn. So pause the video and make sure you do numbers 1 and 2 and determine how many solutions each number has. Okay, welcome back. Here's example 2, solve by graphing. Graph each system and determine the number of solutions that it has. If it has one solution, name it. So they graphed y equals negative 3x plus 10. They also graphed y equals x minus 2. Okay, we should all know how to graph this by now. You start with the y-intercept and then rise over run. Here's the slope. So rise 3, run 1 to the left. For this one, you start at negative 2 on the y-intercept. The slope is 1 over 1, so rise 1, run 1. So these are your 2 graphs. When they ask you the solution, it's where it meets. So this is the point it meets right there. So they intersect at, and this is what, 3, 1. There's 1, 2, 3, rise 1. So this point right here is 3, 1. Okay, not 31, 3 and 1. So the solution is 3 and 1. Okay. Now, here's another one. This one does not look like y equals. So that means you should change it into y equals. So do you remember how to do that? This is right now. Looks like it's standard form. ax plus by equals c. We need to change that to y-intercept. So you want y equals mx plus b. So if you remember properly how to change this so that it looks like y equals. Okay, so that's gone. And I'll continue over here. You have negative y equals negative 2x. That's a negative 2x minus 1. Divide by -1 on each side, and you have y equals 2x plus 1. Okay, so start at 1, rise 2, run 1. So there is your graph right there in blue. Okay, the second portion here. Okay, what I would do is divide everything by 2 so that it looks nice, because I know 4 can be divided by 2, 2 can be divided by 2, and 6 can be divided by 2. So this one right here, I can rewrite it as 2x minus y equals 3. Take away 2x on each side, and you have -y equals -2x plus 3. Divide by -1 on each side, and you have y equals, whoops, actually let's write it over here. Y equals 2x minus 3. So again, you start with the y-intercept -3, 1, 2, 3. The slope is 2, so that's 2 over 1, rise 2, run 1, and there's your red graph there. So as you can see, these two lines are parallel. We actually, before we even graph it, you can see there's a 2x, so that 2 is the slope, and 2x here. So they both have the same slope, which means we already know that they're parallel. When they're parallel, there's no solution. They don't meet at all. So the system is inconsistent. Okay, so this is your turn, numbers 3 and 4. Graph each system and determine the number of solutions that it has. If it has one solution, then name it. So what is the solution if it has one? If not, is there no solution? Okay, welcome back. Here's a real-world example. Write and solve a system of equations. Sports. The number of girls participating in high school soccer and track and field has steadily increased over the past few years. Use the information in the table to predict the approximate year when the number of girls participating in these two sports will be the same. Okay, so their high school sport, soccer, track and field. Alright, so number of girls participating in 2004 in thousands, average of increase 1,000 per year. So if you let the number of girls participating be y, it equals rate of increase times number of years after 2004 plus number participating in 2004. So you have y equals, the rate is 8 from here, times x plus 309 for this one. The track and field, you have 3x, the rate is 3x plus 418. So when you graph these two, the graphs appear to intersect at 22 and 485. Okay, so when you graph it, it looks like this, and where it meets is approximately at 22 and 485. So you can use substitution to check your answer. If you put 22 and 485 in as x and y for each one, x and y. So use that number in each one and see if it's approximately the same. And if they are, then your solution is correct. Okay, so that's the end of the video.